Okay, let's solve another problem. We have here the rigid bar AB is attached to aluminum and steel rod is horizontal before the load P is applied. So this is point A, point B, and point C. Find the vertical displacement of point C caused by the load P, which is equivalent to 50 kilonewtons, and we have to neglect all the weights. Okay, first one is to solve for the forces applied in each rod. So, para makuha natin yung forces na naka-apply dito, we will take equilibrium equations. Summation of moment and then summation of forces. Para makuha natin yung ating equilibrium equations, kailangan natin munang i-drawing yung free body diagram ng ating system. Okay. To draw our free body diagram, this is our bar AB. Meron tayong load dito. Load in steel. So, in-assume natin tension since rod sila ni steel tsaka aluminum. Pag sinabing bar or rod, ang tendency nun ay magkaroon sila ng tension forces. Assume lang naman po yan. Malalaman natin mamaya kung tama yung assumption natin sa kanilang direction. Pag nag-positive yung ating makuha, ibig sabihin, tama po yung assumption ng ating direction. Pag nag-negative po, mali po yung direction na in-assume natin. So, for aluminum rod, assume din natin siya na mag-i-emit ng tension force palabas sa ating bar AB. The load of aluminum. And then, meron tayong weight dito or load P, which is 50 kilonewtons. Yung weight daw po, wala. Neglect daw po natin. So, wala tayong mag-a-act na weight ng bar AB na nasa gitna. Okay, so that will be our free body diagram. So, this is point A, point C, and point B. If we will use our equilibrium equations to get the value of the axial load applied in aluminum, moment lang tayo kay point B. Para makuha naman natin mismo yung axial load na naka-apply kay steel, moment lang tayo kay point A. Para ma-eliminate na natin yung ibang unknowns. So, taking summation of moment at point B first, equivalent to 0, assuming clockwise direction is positive. Pag moment natin to, kay point B, wala nang moment since nandun siya kay point of moment natin. Yung force kay aluminum, pag i-moment natin kay point B, yung galaw po natin is clockwise, therefore that is a positive moment. So, load in aluminum multiplied by a distance of 6 meters. And then, moment natin yung load P papunta kay point B, counterclockwise, negative moment. So, that is 50 times a vertical distance of 2.5 meters. So, wala na tayong moment, that will be equivalent to 0. So, solving for the axial load applied in aluminum bar, calculate lang po yan, transpose and then divided by 6. And we will get a load of aluminum which is 20.83 kilonewtons. So, gagamit po natin yan. And then, for the load applied in steel, moment lang tayo kay point A. So, taking summation of moment at point A equivalent to 0. Taking clockwise direction is positive. Wala nang moment yung load in aluminum. And then yung load P, papunta kay point A, clockwise direction. Positive moment po yun, 50 times a vertical distance of 3.5. Yung load kay steel, papunta kay point A, ang galaw po ay counterclockwise. So that is negative moment. So load in steel multiplied by a vertical distance of 6 meters equivalent to 0. So solving for the load applied in steel, we will get a value of 29.17 kilonewtons. So, meron tayong mga load kay aluminum tsaka kay steel. So, pag may load P ka dyan, may load P ka doon, may P, may L, may A, may E, ibig sabihin, masosolve na po natin yung kanyang deformation dahil meron tayong plae. Same with steel, may load na kay steel, P, may L, may A, may E, masosolve na din natin deformation in the steel rod. So, solving for that, deformation of aluminum, that is PL over AE. So that will be equivalent to load P in aluminum, 20.83 kilonewtons. Pupunta lang natin siya kay newtons. So, gagawin natin newton, multiplier natin will be 1 kilonewton is to 1,000 newton. Cancel na po yung kilonewtons. Naka-newtons na po. Multiply by the length. The length is meters. So, solve lang natin. Dapat naka-mm lang po yun. So, that is 3,000 millimeters. Nag-multiply lang po ako ng 1,000 para maging millimeter yun. Over the area. Area is 300 square millimeters multiplied by the modulus of elasticity, 70 gigapascal. Ang 70 gigapascal po ay 70,000 megapascal. So that will be 70,000 megapascal. Ang megapascal po ay newton per mm squared. So, naka-newtons tsaka mm na po lahat yung units natin. Ibig sabihin, ang magiging unit ng ating deformation in aluminum is in terms of millimeters. So, solving for that, calculate lang po yun. Direct sub, we will get 2.9757 millimeters. And then, solving for the deformation of the steel, that is steel PL over AE. Ang load ni steel, na-compute na natin kanina, 29.17. Gagawin lang po natin siyang newtons, 29.17. Multiply lang natin ng 1,000. And then, multiply by the length of steel, nakalagay sa ating problem, 4 meters. Gagawin natin millimeters, magiging 4,000 millimeters. And then, over the area of the steel, which is 500 square millimeters, multiplied by the modulus of elasticity in steel, 200 gigapascal. Ang 200 gigapascal ay 200,000 or 200 times 10 raised to 3 megapascal. Dahil ang megapascal ay newton per mm squared. So, substituting 200,000 megapascal newton per mm squared. So, naka-newtons to. Kakancel yung newton. Kakancel yung mm squared. Matitira ay mm. So, the deformation of steel is equivalent to, direct sub lang sa calculator po yan. That is 1.1668 millimeters. Yan, may mga deformations na tayo. Since nasolve na tayo yung deformation ng ating dalawang rod, next one is to solve for the unknown, which is the vertical displacement of point C. So, paano daw gagalaw yung point C? Ano daw yung displacement niya? Vertically. So, para ma-solve po natin yun, dapat ma-analyze po natin kung paano ma-deform yung system. Paano siya gagalaw. Kung papansin po natin dito, yung load P natin ay pababa. So, yung tendency nun, hinihila ni load P yung system natin pababa. Pag hinihila ni load P yung system pababa, magkakaroon ng elongation si steel tsaka si aluminum. Yung bar AB po natin ay walang deformation since yung bar AB natin ay rigid daw. Pag sinabi natin rigid yung ating body, that is assumed to be infinitely strong. Ibig sabihin, kahit anong load yung i-apply po natin, hindi po siya ma-deform. Okay, so may deformation lang ay yung aluminum tsaka steel. So kung ating do-draw yung ating deformation, para makuha natin yung compatibility equation natin, ito yung original position ni bar AB, magkakaroon daw ng deformation yung aluminum. So yan yung kanyang paggalaw, pababa. And then also, makakaroon ng deformation yung steel rod natin, pababa din. Yan, papansin nyo, mas mahaba yung deformation na drawing ko kay steel. Bakit po? First one is mas malaki yung length niya. Papansin natin sa equation, deformation is directly proportional to the length. So, ibig sabihin, pag lumalaki yung length dito, lumalaki din yung value ng deformation. And then, secondly, kung bakit mas mahaba yung deformation steel, mas malapit po yung load P kay steel rod. So, yung tendency nun, mas malaki po yung load na makikerry niya. Papansin naman po natin, compared to aluminum. Pag mas malaki po yung load dito, mas malaki din yung value ni deformation. Since that is directly proportional to each other. Okay, so yung magiging galaw. So, ibig sabihin, ito yung final na itsura ng ating system. Nandito na si point A, nandito na si point B. So, ito yung deformation ni aluminum, ito yung deformation ni steel. Ang tinatanong, ano daw yung vertical displacement at point C? Assume natin, y of C yung ating unknown. So, para makuha natin yon, we will use ratio and proportion. Pag sinabing ratio and proportion, dapat meron tayong similar triangles. Nasaan yung similar triangles natin dyan? Nandito po yan. Yan po. So, hiwalay po natin yung ating triangles para mas ma-analyze natin mabuti. Mas paayos. Ito na po yung triangles natin. Yan po. Ito lang po yung ating inanalyze. So, ano to? From this point to this point. From this point to this point, yan yung deformation of steel. Kaya lang, from this point to this point, deformation of aluminum. Tama po ba? So, pag kukunin natin to, that is deformation of steel minus deformation of aluminum. Nagigets po? So, ito naman yung i-analyze lang natin. From this point to this point. From this point to this point, that is the vertical displacement of point C. Kaya lang, para makuha natin to, ma-minus natin yung distance na yon. Ano ba yung distance na to? Deformation of aluminum. Therefore, ang distance na to is vertical displacement at point C minus the deformation of aluminum. This is 3.5 meters and this is 2.5 meters. So by ratio and proportion, we can say that this small triangle is similar to this larger triangle. So by ratio and proportion po yun. Base is to base, height is to height. So the base of a smaller triangle corresponds to the base of larger triangle. Equivalent to the height of smaller triangle, 3.5 meters, corresponds to the height of larger triangle, a total of 6 meters. Cancel po yun. Ang kinukuha po natin ay yung vertical displacement at point C, which is y of C. So, ilipat lang po natin lahat ng parameters sa kabilang equation. Ang matitira lang po dito dapat ay yung y of C. So, y of C is equivalent to, by ratio proportion, or by, what they call that, cross multiplication, that will be 3.5 over 6 multiplied by the deformation of steel minus deformation of aluminum. Ito nang natira doon pag transpose natin yon, and then merong matitira pang deformation of aluminum. Transpose natin doon para ito lang matira. Plus deformation of aluminum. So yun po yung magiging formula. Therefore, substitute lang po natin. Meron na po tayo lahat ng values na yan. The vertical displacement at point C is 3.5 over 6 multiplied by the deformation of steel 1.1668 minus the deformation of aluminum 2.9757 plus deformation of aluminum 2.9757. Therefore, we can get the vertical displacement at C will be equivalent to 1.921 millimeters. And that will be our answer for this problem.